Hello everyone, my name is Martin, and what I'm going to show you now is a demonstration of the StructureMining app of PDF in the cloud. I will take my starting point in some of my own data, which concerns nanocrystalline titanium dioxide with rutile structure. What this demo includes will be structure mining for data for a single phase or phase pure material. However, we will also include structure mining for a two-phase sample, where I will try to identify the primary phase initially, but then I will also, from the residual curve of a single-phase refinement, try to identify the nature of a secondary phase. So let's get started. So my science case is that I have a series of titanium dioxide materials with rutile structure, and they have been synthesized hydrothermally, where the duration of hydrothermal treatment has been varied. So it goes from 3 hours to 6 hours, 9 hours to 12 hours. And as you can see, readily see, well, they all have the same Bragg peaks. However, the shorter the duration of hydrothermal treatment, the broader the peaks. However, if we consider the 3-hour sample and the 12-hour sample, well, the 12-hour sample seems to be phase pure, whereas the 3-hour sample seems to have, for instance, a bump here before the first Bragg peak, which kind of indicates that there is some secondary phase, which is very disordered, present for this material. Let's start out with the 12-hour sample. So what I did before I got the chance to work with or use pdfitc is that I did a single phase refinement using the rutile structure as the only phase included in the refinement, and I obtained a weighted residual of 14%, which is decent, but indeed it seems like I'm missing out on something on the especially on the very local level of the structure. But as I said before, the fit is decent. Let's see how pdfitc performs or what it suggests. So let's go to pdfitc here. So what we do here at the front page is that we will click start for the structure mining app. And here we have the chance to upload a file. So let's start out uploading our 12-hour or the data for our 12-hour sample. It is an X-ray probe, and I am relatively confident in the chemical composition being titanium dioxide. As optional parameters, I state the dampening effect of the instrument that I used, which has been refined from a crystalline standard, and the same goes for the broadening effect from the instrument, which, however, refined to practically speaking 0. And then I will state the Qmin used in the Fourier transformation together with the Qmax used in the Fourier transformation. And then I'll state that the data is experimental, and I'll submit. And immediately, I'm told that 82 matches or structures were found matching our chemical composition of titanium dioxide. And right now the structure mining goes on. However, due to time concerns, we'll jump to the result, which is stated here. And you can see out of the 82 structures matching our chemical composition, well, 13 of those had a weighted residual lower than 50%. And well, the first 30 will be from 0 to 12. And indeed, all of those structures have the same space group, which happens to be the space group of rutile. Yay, I'm happy as a user. However, let's see what goes on if I try to structure mine for the data for this two-phase material. So initially, I just did a single phase refinement and using the rutile polymorph, and again, it's a decent fit. However, the weighted residual is a bit higher. It's now 18% instead of 14. However, let's look at the residual because it is a bit different from that of the 12-hour sample, and it is especially this at least to me, a bit odd-looking difference curve or residual curve that it caught my attention. Let's try to see what pdfitc suggests if I just try to capture the primary phase. So again, we go to PDF in the cloud, we start the structure mining app, we upload our data. Now we do it for the 3-hour sample. It's still X-ray data. We still think that the composition is titanium dioxide. Now I'll do a shortcut because my browser remembers what I put in before. It is experimental data, and I'll submit. And again, not surprisingly, we have again 82 structures that match our chemical composition. Let's jump to the result. And here we see that, okay, now 14 structures have a weighted residual lower than 50%. So from 0 to 13, going from the bottom, all have the same space group except the topmost. And indeed, that was a bit surprising to me. So from 1 to 13 is the space group of rutile. However, the topmost is some other polymorph of titanium dioxide. So what I did was I took this residual, saved as a GR file, which we can now upload to pdfitc. So we start the StructureMining app. Now, as the data, we choose the residual curve here, which I saved as a GR file with the same specifications as the original data. Now it's still X-ray, and now I assume that it is still titanium dioxide. And now we can state again the same parameters as before. And again, my PDF is experimental, so I submit. And it is running. And let's jump to the result, which happens to be that we have no structures with a weighted residual lower than 50%. And indeed, we have no one. The lowest one is almost 87%. However, remember what I uploaded as my data was my difference curve, or my residual, which should basically contain noise and, well, the features that I miss out in my initial fitting. So I should kind of expect a poor agreement in this case. However, what is interesting to me is that the first 10 structures suggested have the same space group, and it happens to be the space group of anatase, which is actually the phase I arrived at myself without pdfitc. However, to arrive at that, I had to spend a lot of time because I had to browse through a lot of polymorphs. I basically had to do the job that pdfitc StructureMining app does for me. And indeed, this is really nice as a user. Okay, so this was the initial single phase fit. Now the 2-phase fit, including the anatase phase, the weighted residual only goes from 18% down to 17%. But what is worth to note is that if we inspect how the difference curve looks, initially it looks a bit odd. Now it looks, well, more familiar, especially because it actually resembles the residual for the 12-hour sample. So basically, my claim is now that by including this anatase phase, even though the weighted residual didn't change a lot, we basically obtain a model which kind of captures the same, or what should we say, what we miss out in for the 12-hour sample is basically the similar things that we now miss out for the 3-hour sample, right?